Hey there, and welcome to Into the Terminal, episode 64. My name is Eric the IT Guy Hendricks, and joining me every episode, more or less, is Scott McBrien,
Hey, Eric.
Mr. Server GUI himself. So today we are going to be continuing our mini series, our episode arc on security and how OpenSCAP profiles and security profiles all align towards making our systems more secure based on security profiles. Today, we're going to be talking about system auditing. This is incredibly important when you look at applying security policies like CIS or HIPAA or any number of others. Because if your system doesn't meet those requirements, it's good to know what tools you have available to check to make sure that your system is in compliance, fix the things that aren't, and really understand what's going on underneath the hood. So we're going to look at a few different tools. And so in the critical path, we're going to go ahead and take a look at those tools and how to configure them and how to use them, and then we'll talk about applying some rules and whatnot in the deeper dive. All right. So with that being said, we're looking at a RHEL 9 system here. 9.1. For those of you following along, 9.2 just entered beta this week. So free advice to go check that out. So whether it's our lab systems or by default, I failed to check beforehand, but we actually have the auditd, which is the first tool we're going to look at, is already installed on our system. So you notice here that we've got the audit package version 3.0.7, and all that is already installed. So let's check on the auditd, which is audits daemon. Let's check and make sure that's running on our system here. It is indeed running. That's always a good sign. So in the deeper dive, we're going to look more at auditd and some of the rules. But to get an idea of what is going on underneath the hood here, let's do an auditd CTL, and I'm actually going to clear my screen so it starts off at the top. There's no rules. So
We'll be adding rules in the deeper dive.
So just in case you want to check your own system, that command was auditctl-l, and we'll do more with the auditctl command a little bit later on in the episode. So that's auditd. Make sure you've got auditd set up and running on your system, and then we'll talk about how to apply rules in the deeper dive. The second tool that we're going to be looking at today, we actually had an episode early on Into the Terminal on session recording. And so we're going to let's go ahead and take a look at session recording, and let's get those packages installed. So session recording is built off of a utility called tlog. And then I also want to, because I'm a very visual person, I want to be able to configure tlog using the web console. So we're going to go ahead and do a DNF install on those two packages. Thank you all, those of you that are joining us live. And then, okay, so we've got tlog and cockpit session recording installed. Let's go ahead and also, I do believe that we need to restart the cockpit socket to get the, it should be cockpit.socket. To get go ahead.
Sometimes that's needed, but in my testing earlier today, I noticed it just showed up over there.
Yeah, it seems like certain plugins, certain packages will go ahead and reset that socket for you. Others you need to do by hand. So I'm going to go ahead and reconnect here using our super secret user and password. Okay, so this is the web console. We've got episodes on web console and session recording in specifically, but we're just going to go through real quick. Of course, we don't have any recordings just yet, but we're going to go ahead and configure a couple of things on our system here. General config, we want the shell to be bin bash. We want to put a notice that the session is being recorded. That's kind of the main things that you want to start out with. Then under SSSD config, we want to basically decide what accounts or what groups that we have available to us. that fall under session recording. Strangely enough, on the stream here, it's not showing you the drop down menu,
Are
but
you
we can set it up as some for users and groups. We'll do it this way so you can see what's going on. But for the sake of the critical path, let's go ahead and just actually, interesting enough, under some, this is an include list, but under all, you can actually exclude users or groups. But let's go ahead and save this. Again, this is our critical path, so we're just going to real quickly go through and look at what's going on here. And just to test our configuration, let's do an SSH back to our local system here. And then so notice that, in fact, our session is being recorded. So if we came in and did some stuff, we could then later go back and review this recording. Okay, so that gives us auditd is up and running. Session recording is up and running. The last thing I want to do is install a utility called AIDE. AIDE, Scott, maybe help me out here, is actually an acronym, I do believe.
It's something like audit and intrusion detection, something, something, something.
Yeah,
And
I'm terrible with acronyms, but AIDE is really helpful in doing some of these intrusion detection type things. It looks for patterns. So once you have the package installed, you want to do an init that basically sets up a database that we'll look at here in a minute. So once you kick that off, don't worry that it doesn't come back immediately. That because it takes about 60 seconds or so, at least on our lab systems. Keep in mind, these are very vanilla, very small systems. So it takes about a minute for that database to get configured. So with all of that said, that gets the three tools that we're going to look at today set up and ready to go for our deeper dive. With that said, in the second half of the show, that's when you can throw your questions into chat, hang out with us live, and Mr. Scott McBrien will be taking us deeper into session or system auditing. With that said, let's go ahead and dive into that. All right, so episode 64. We are chugging right along. Thank you all for joining us live. Scott, this is kind of a bittersweet day for me. This is my last official day as one of the hosts of Into the Terminal. I'll be moving more into a bit of a producer role, and instead, Mr. Nate Lager is going to be joining us here in a couple of weeks to be the new regular host. Of course, if either of you need a day off, I'll be there to jump in. So I'm not going far, but yeah, this is kind of bittersweet. 64 episodes. We started off with like a 30-day daily episode, 2-a-days there for a while as we had two different showings of this. So, bittersweet day, but Nate has a much bigger passion about this level of technology than I do. And he's really proven himself as an amazing podcast host and also as one of our hosts in the RHEL BU. So, I'll miss you guys, but again, I'll be in the chat and I'll be producing the episodes from here on out. But really a bittersweet day.
yeah, well, the viewers may miss you, but I get to work with you every day. So it'll just be like, see you in the meeting this afternoon.
Right. Oh, for sure. But Nate will do an awesome job. I'm really excited to. He's got some new ideas. He's got some ideas for some episode arcs. So really excited to see what Nate and Scott do with this with the show moving forward. But that said, you're not rid of me yet. So we've got some system auditing to talk about. So why don't we dive in?
Yeah. So in our episode guide, we have auditd first. I think I'm going to actually push that until later because we ended the critical path on AIDE, and I think that one's a pretty straightforward one to get going with. So when we ran the AIDE-init, it created a database, and that database is stored down in var lib AIDE directory. There it is right there. It's a gzip database. And what it has in it is a whole bunch of checksums and metadata about the files on our machine. And so before we do anything else, we could do something like check the database. And I'm going to get an error on this. Because it turns out that when we create that initial database, it gets created with the file name aidedb.new.gz. And you can see that when we do a check against that existing baseline database, it actually says, wait, I can't find it because it doesn't have the right file name. So before we do anything else with AIDE, we need to move that baseline into the correct file location. All right. So now we can do an A-C and it'll come back without anything because I haven't done anything to the system yet to mess around with it. But maybe I should. So maybe I should add a new user. Eric likes to add Jim. And after I've now made a change to the machine, I can then run my A-C to check the database. And what it's going to do is take a look at the same checksums and file metadata across my machine and compare that with what was stored in this baseline database that we created a few minutes ago. And it should come back with a couple of things that have changed because we actually did modify the content of files when we added this new user, Jim. All right, and as Eric pointed out in the critical path, if you have a large system with lots of files, this will take longer because we're actually introspecting each individual file and directory on the machine. All right, I see that Conan Kudo asks if there's a reason why the AIDE database doesn't create the baseline automatically. And yes, it doesn't create the correct file name automatically because if we ran the init again, it would overwrite our database with a new baseline. And that may not be what we want to do. We'll actually be updating the baseline in just a minute. All right, so here we are. We got our check back. We see that there's differences, right? Because it actually like showed us a whole bunch of stuffs. And when we scroll up through the differences, we get a nice little preamble with some details, right? So these are the things that have kind of changed since the baseline. And we can see things like the Etsy password file has changed and the shadow file has changed. And I actually changed my SSHD config because I wasn't paying attention and I needed it to be updated. So all these files have changed since the baseline was established. But when we look at this list, it's like, oh, well, that kind of makes sense, right? Because I was doing things like configuring session recording, and I added a new user and group, and I actually the PAMD stuff all happens to deal with session recording as well. So those changes are to be expected. And I could do other activities too, like maybe I apply some updates. Well, if I'm applying updates, what we're really doing is replacing the files and binaries on disk with new versions of those things. So now we're actually swapping out whole files, not just adjusting the content of them, but actually like replacing them with the files from these updated RPMs. So again, if I run a-c to check against my baseline database, I should now see things like the Vim executable has changed. All right, so we're going to take a look at that real quick, and then we're going to be like, okay, but these are all normal things, right? I expect a user to be added, or I expect that it would highlight a difference with the baseline if I added a user, or I expect that the baseline would be different if I applied updates. So now that I know that I've changed it, I need to re-baseline my system to account for its current state. But where AIDE is interesting is if you had not been doing those things and you come in and do an AIDE-C and all of a sudden there's all these changes, it's like, well, how did that happen? I didn't perform any activities that would have made changes. So why are there changes on the system compared to the baseline? And that's what AIDE is used for, is to like compare the current state of the system against a known state of the system from the past and report on differences. All right, so let me take a look at my my list here. Let me scroll up to the nice a nice list of changes. Okay. So we see that there's some differences in the attributes for some files. We see that there have been added files of 23, and we removed a couple of files, and we updated 16 more files. And if we look through the list, we can actually see what was added or removed or changed, right? So we can see that these user lib something somethings, those were removed. Those were symbolic links. And then down here, we can see vim was changed and this xxd command was changed. And that's because of the update I applied to the system. All right. And then it goes into a little bit more details on what the individual properties are for the files that have been modified from my baseline and what about them is different compared to what they look like today. All right. So we said that we kind of expected that though, because we were doing system administration tasks. They're going to change files and stuff on the system. So now that we have updated our system, we need to re-baseline it so that we can now say, this is what the system looks like today. This is what a known good state looks like. So in the future, when I do an AIDE-C, I can check against that known good baseline that I just updated. So we're going to, again, aid-init. And this is why Conan Kudo, we don't just like drop it in the right directory with the correct file name, because if it did, it would overwrite our previous baseline. So if we accidentally ran an init, we'd actually be updating the baseline, which may not be the intent. Now, there are some other commands that you can, or options you can pass with AIDE to like tell it what file name to create if you actually wanted to not have to move things around once the database has been created. All right, so here in user lib aid user, try that again, var lib aid. So there's my ADB GZ, that's my old baseline, my ADB new GZ, that's my new baseline. And so by moving the new baseline to be the correct file name, now I've rebaselined my system. And when I do an A-C Apple C, it should come back with no changes because I haven't made any changes since the last time we baselined the system. So that's what a clean AIDE check is going to look like in just a second as we crunch through the entire system, verifying all the metadata and files are still correct.
Being able to see what's changed not only helps you with your system management, but it really helps in those situations where maybe someone is coming in and doing something nefarious, like granting themselves access to systems that they shouldn't and changing configuration files in, say, the etc directory.
Right. Or adding user accounts for themselves that you may not notice, things like that.
Mm-hmm.
All right. So this is one thing that we can do, verify the file system and its integrity and its contents using AIDE. One of the other things that's common in a lot of the security standards is using auditing. And as Eric pointed out in the critical path, on these machines or on our machines, audit was included automatically, but you'll want to make sure that it's there on your boxes. And here on my system, I've also created a couple of additional files for rules. So in etc audit rules.d, I created the chmod rules and the unauthorized files rules. And essentially, what these rules are is I want the auditd daemon to keep track of when these events happen on the system. So It is always and at exit on 32-bit or 64-bit systems. Verify or log when the chmod command is executed. And make sure that that happens for every user ID over 1,000, but not this 4 million something, 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 which is the nobody user, right? Because some services run as that user, and we don't want to include those in our rules. And then key is like a reference that we can use for looking at these events. So in the audit log, it would have the key in the log contents. So we can identify like what rules were tripped in order to get the log that was generated. All right, the other thing, the other rules that I created. All right, so this is, I want to, on 32-bit and 64-bit systems, look when the exit code is error for access or error for permissions. And so if you're trying to create open add, I don't know what the system call is for that one, open by file handle, truncate, ftruncate. If any of those occurrences happen, any of the system calls are made, and the user is denied access or denied via permissions from doing those things, that's what I want to log. And so that's what these rules are doing. Okay, so let me do my auditctl -l. I can see my rules. Oh, wait. As Eric noted earlier, there are no rules loaded. That's because auditd rules are loaded at boot. So I can create these files, but it turns out I can't get them actually loaded into auditd unless I reboot the machine. So if you're working with auditd and you're working with audit rules, be prepared to have a maintenance event of needing to reboot your system in order to get those new rules changes into effect. All right, so let me go ahead and reboot the box. So Eric, how's it going?
Well, you must be doing a fantastic job because the chat's pretty quiet today. So I think everybody may have that spring break fever going on.
Or they're bored because there's nothing blowing up for our systems.
Well, see, this is why we shouldn't test things ahead of the episode. It's just then it's just an explanation. It's not an adventure.
All right, so the system has come back from its reboot, and now if I do a auditctl-l, right, there are the additional rules that I had put into my auditd configuration, right? They're loaded into the auditd daemon. And I like working with the rules through the etc audit rules.d directory. So you basically just drop files in here that have the extension .rules. It's important that they're called something .rules because the auditd daemon will kind of cycle through this directory and slurp in all the content from the rules files. It also allows you to package up rules that go to specific targets. So if you wanted to make some rules that apply to some boxes but not other boxes, you could actually control what files are propagated to them at your leisure. All right, so what does all that mean? Where did I get these rules? I didn't just write them on my own because I'm not that smart. In fact, they were provided to us through a document at openscap.org. So SCAP, you may recall from a previous episode, is a scanning utility that will assess your compliance with a security standard. And Red Hat does a ton of work with OpenSCAP. We also do a ton of work with the security guides for Red Hat Enterprise Linux. And in the Disastig security guide, there's this checklist that says, here's a bunch of things that you need to have in your audit configuration to comply with the STIG. And this is something that the OpenSCAP utility would also validate when doing a scan. And so that's where I got all the actual rule content that I put into those files that I made for us to take a look at. All right, so returning back to our screen here. All right, so I'm going to just split my screen here. And I'm going to do a tail -f on var log audit log. All right, so as we're doing stuff on the system, like SSHing into it, you could see that that SSH is generating audit events, right? And so if we start violating those rules that we had already put in place, those would also generate audit events. So you could go through the actual log and take a look at that. Or maybe you want to use a tool. A tool like AU report. So AU report just reports on what's happened in your auditing. And let's pipe that to less. All right, so it just gives you a report of what's been going on in your audit logs. It will by default report on everything that's available in the log files. And so you can see things like failed logins and number of users and how many terminals have been invoked and other stuff, right? So there's a bunch of events that get logged. You can also do searches. So I can do AU search for a specific person. So the RHEL user account is user ID 1002. But these are all of the audit rules that have been, or all the logs that have been generated by audit rules for this person. So I can look at things like, oh, they logged in and they went through SSH and et cetera, et cetera. So this is how you can report on what's actually stored in all of that auditing information. So auditing information is really good for logging system events and stuff like when people do things that you are not expecting or you want to keep track of, like failed to change permissions on a file because they shouldn't be doing it or they don't have access to do it. Or you could do things like every time someone runs the chown command, regardless of who they are or what they're choning, I want to know about it. Or every time somebody reads a file, I want to know about it. So you can get really broad in your auditing and like start pulling all that stuff into the audit logs. But here's one other thing. So while this is all good, that you can have all these system events, and a lot of them maybe you didn't know because they're being driven by applications and other stuff. The other thing that we set up in the critical path was session recording. And why I think session recording is a really good augment to this topic is because in addition to knowing what people are doing in terms of like the events that they're triggering or the rules that they're bumping into, you can also actually watch their sessions by looking at the recorded information from them. So Eric, earlier in the critical path, he took care of doing a session recording configuration for us, which is fairly simple. And we're going to go ahead and SSH to our own machine. And when we do that, we get that notice that the session is being recorded. That was part of the configuration that we applied. We can do some stuff. All right. And then when we're done, we can exit our session and it's been recorded and encapsulated so that we can review it later. So one of the interesting notes that we have for configuration, when Eric went through and and did the initial configuration, he took all the defaults. And one of the defaults was that we are using journaling, the journald daemon, as our repository of session recorded data. You could also change that to syslog if you wanted it to go somewhere like varlog messages or be sent to a remote host through remote syslogging. So there are options there for how you store these, but they're stored as text. So if we take a look at our journal log, sorry, I'm copying and pasting because typos suck. What I'm doing is saying, hey, look at the journal log and show me the entries that look like this with my grep, right? And it's basically like has the term rec in quotes and then some stuff and then a comma. So this is what was the session that we just recorded. So every recorded session has a unique UUID, and I just like used my grep to highlight what that is, right? That rec colon and the UUID. And from knowing the session ID unique identifier, I can replay it. So I can use tlog play, and I can play it from the journal. And I want to use the tlog recording ID and this string. Oh, let's try that again. And this string. There we go. And so here we are watching the session play again, right? So I started it and I talked a little bit and I ran df and then I looked at this password file and then I ran a command and that didn't work. And I ran it again and I ran it again and I ran it again. And then I asked which command it was, like where it was located on the system. And then I closed the session. All right, so that's what happened during that session. And we were able to replay it from those log entries that we stored in the journal log, or if your configuration said otherwise, to put it in syslog, we could have found it there too. So why do I think it's super important? So Eric, have you had the experience where somebody calls you up and tells you that Flask isn't installed in the system?
Yeah, I've run into that from time to time, and you really want to be there sitting next to a person. But if you're a remote call center or something, you don't have that option. But nowadays, you actually do. So you can go find that user, look up. So last time I tried was 30 minutes ago, and it's still not working. You can go find their session, see what it is that they're doing, see what they're trying to do, and then troubleshoot that issue.
Yeah, and so like you could say, well, what error did you get? And they're like, I don't know, it just gave me an error, right?
It's just not working.
Well,
It's broken. Fix it.
Exactly. And then you like can look at something like this and be like, oh, well, the reason that you're having problems running the Flask command is because you didn't actually run that command. Right? And, oh, look, here it is. And it says command not found because it wasn't found. And when you ran which, it's not there because there's no such thing as flarn.
What I picked up on during the replay was when you typed which, you did a space C instead of space F, and it recorded that. So even as you're correcting typos in your commands, it's recording all of that.
Yeah. And the other thing is like not only does it record the output of the commands, but it also records the error messages that you get. So you actually can kind of recreate the session in its entirety and how the user experienced that session. All right, so how does this complement the other stuff, right? So I find in my audit log that some event happened and it's got a date time stamp on it. And then I can look and see like what sessions were happening during that date time stamp. And then I can replay them and actually see like not just that they tried to access a file that they didn't have access to, but actually the stuff they were doing before and after and during that access to figure out whether it was accidental, on purpose, malicious, maybe it was like they ran a command that actually touched that file and they actually didn't know that they were violating the policy at all because it was some application that was doing it on their behalf, right? So that's why I think session recording is a great complement if you are being asked to also do very severe auditing so that you can get this better picture of what's actually happening during those auditable events.
So there was, yikes, that was scary. Sorry. That's better. That's our usual view. Clicking all the things. There was one last question. Just got to scroll up and find it here. I think it was this pre-link question from Shantanu. So is pre-link still a thing on RHEL 8 and 9? Will it detect changes to the SO files? I think that was the question. Let me double check here.
It's been a long time since I've been asked about pre-linking. I believe so, but man, I am super unsure in that answer. Will it detect changes in the shared object files? Yes, because shared object files are stored on disk and are provided by an RPM, right? So if you applied an update, which updated the shared object files, then yes, AIDE would detect those changes. Now, I think the other aspect of that is if the program was already running and had loaded the shared object file into memory, and then you did the update on disk, does that change what's in memory? And the answer is no. So that's why for things like a glibc update, we now recommend that you reboot the system after applying that update so that all the applications that may be affected by the loaded into memory content from that update will actually get the updated shared objects and other library data put out for them. So just because we install a package on disk does not mean that it affects the running executables and what's currently stored in memory. So a lot of times, in fact, we have a command called tracer that's part of the web console update manager, as well as satellite, that will tell you that we recommend a system restart when you apply certain updates. And that's why we recommend system restart, is to make sure that what we have in memory matches the newly updated files that we applied to the system.
I totally knew all of that. Don't tell Scott I had no idea. All right, so that so this was a little bit longer episode, but I think it was really important because over the next few episodes we're going to be wrapping up our OpenSCAP security profiling story arc. So it was we wanted to highlight some tools that'll help as you go in and look at actually selecting a profile, building your systems out to match that profile, and understanding why certain things aren't working, or understanding if there's nefarious or extra things going on in your system. So we wanted to kind of not really take a pause, but to look at some tools around this idea of OpenSCAP profiles. So with that said, next Friday there will be no episode, as pretty much all of us will be on spring break. So definitely you can come to the RHEL YouTube channel, but we won't be here. But take that as an opportunity to check out one of the other 63 episodes of the Into the Terminal backlog. We've got all of those in a playlist, and I'll try and get a short link for those. RHEL Presents has one, but not Into the Terminal. So note to self: when I go back to write the show notes, I need to make that. So note to the producer, who's also this guy. But we will have RHEL Presents next week. We'll be joined by John Spinks. Recently, Red Hat Insights just got even better as we added a malware detection service. So join Brian Smith and John Spinks and myself on RHEL Presents next Wednesday as we cover that topic. Meanwhile, thank you all so much for joining us. Really appreciate it. Whether you watch live or after the fact, always enjoy engaging with you in the comments. Scott and I are really good about checking those, whether it's just episode feedback or whether you've got a technical question. Really appreciate the feedback, the engagement in chat. If you want to join us for live conversation after the fact, that way, over up yonder, there. Yeah, over there above Scott's head right now is a QR code. Join us live on Discord. The Enable Sysadmin, the Enable Sysadmin community was kind enough to give us an Into the Terminal and RHEL Presents room. So scan that QR code or grab the link in the show notes. Keep in mind, usually a couple hours after we're live, I add documentation links, episode links, and additional resources in the show notes below. So definitely check those out after the fact. Until then, on behalf of myself, my co-host Mr. Scott McBrien, our incoming host Nate Lager, and all of us on the Red Hat Enterprise Linux team, thank you all for joining us. Have a great weekend, and we will see you next time.